this is it's a key. The key of knowledge. Get it? Because it's a key. Now basically today we'll talk to you about the solubility product constants. The solubility product constant, known as KSP, is the equilibrium constant for a solid that is in equilibrium with the solid dissolved ions. But remember, before solving any KSP equation, you must know that you have to balance both equations.
Hi, my name is Dr. Hamid al-Midbil. I'm a physician, but in my pre-medical years, I studied chemistry. I have a bachelor's of chemistry from Harvard University. Chemistry was a big thing in my life. In high school, when I was thinking about pursuing a career in engineering or like a medical career, chemistry made me love science, especially once I remember we had a teacher called Mr. starts with a Z. Yeah, Mr. Ziringzura. Yeah, he's the best chemistry teacher I know. Once we came across this thing, this section, this chapter, call it whatever you want. It was calculating the concentration using the KSP. At that time, I was excited. The desire has built up in me until I chose chemistry to be my bachelor. I loved chemistry at that time. Well, I think my duty today is to teach you guys the real meaning of calculating ionic concentration using the KSP and the solubility and all that stuff. Trust me, put it on me, put it down on me, and you will never fall.
Hello, my name is Professor Ayman and I'm from Ireland. I work in the Trinity College in Dublin. Today, Dr. Hamid and me are going to team up and going to calculate the ionic concentration of using the KSP. So let's go right now.
Okay, here's Dr. Hamid and I'm back again. Here's the question. The KSP of P2Br is 6.610 at 25 degrees Celsius, which is the concentration of Br when the resolution of the aqueous. Nice, it's an easy question as you can see. Now for step 1, let's do the answer. First of all, now, so we can get the answer, we have to get the equation. We have to use it, we have to do it, we write an equation here from the question given, so we can do the rest, okay? For my equation, I'm gonna write PB, that's the first step, PB, BR minus 2, No, before I continue, as you can see here, we got this from here. So now we have to balance the equation by doing this. PB plus. Okay, now we balance the equation. Oh, there's a common mistake. As you can see, this is not it's a mistake I did on purpose because people forget it all the time. And as you see, there should be a 2. I'm gonna write it in red so people don't forget it. This is the common mistake. Now, for the next step, since they're using the equation above, we can express KSP as KSP equals. Now, as you can see, it's KSP equals. Then we're gonna put in bracket close the bracket. Are we done? No, we are not done. We're gonna put another bracket BR minus times 2. As you can see, we got the equation right here. Since there's a 1:2 ratio between PB and BR, if the concentration of PB plus ions is X, then the concentration of BR minus ions is 2X. So, I'm gonna write 2 KSPs. KSP equals KSP equals. We're good right now, so we're gonna do X times 2X. I'm gonna close the bracket, then it's all to the power of 2. Nice, this we got the first one done. For the second one, we're gonna take from the question, so it's a 4x. So it's a 4x to the power of 3. Okay, we're good right now. I know it's easy, people are following on with me. I think this is in the simplest form, and I guess there's nothing hard about this question. So find x, the molar solubility. So what we're gonna do, we're gonna times them, then put them again together. So we're gonna do 6.6 cool times 10 to the power of 6. So this we're separating them so people don't get confused. Times 6 to the power of 10. So we're moving on right now, so we're using our calculator. We're gonna get 0.0118 and capital. Okay, so here's the question. So we're gonna divide it will equal to x. So our final answer will be x. But there's something we have to remember. That this is not the complete answer. The complete answer is to take 2x, nice, 2x, then 2x, 0.0118 t equals 2.4 times 10 to the power of 2 and here is the complete answer. As you can see, from step 1 to the last step, I think there's no problems, because I think it's an easy way to do the questions, easy way how to balance them, and everything in this question is simple and self-explanatory. Thank you very much, and Dr. Ayman, Professor Ayman will be next, and he'll explain something else.
Thank you, Dr. Hamid. Now it's my turn to explain the question. Anyways, let's read it down. Copper 1 chloride has a solubility product constant of 1.2 times 10 to the power of negative 6 and dissolves according to the equation below, which is right here. Calculate the solubility of the salt in ocean water in which the chloride minus equals 0.55. First of all, you need to know that we don't use the solid, we only use the aqueous, so we can leave that out. Second thing, you should underline the important stuff, like this, because we lose it really shortly. Now, let's find your work. Just down copper plus and Cl minus equal the KSP, which equals 1.2 times 10 power of negative 6. So, after you establish that, then you can write down how the equation should look. See, after you start something like this, then you can finally do the last part, which is probably the easiest. Using the following equation, you can determine the concentration of the copper ions. So we'll do it like this. So it's basically just plugging in the numbers like this and write down Cl, because you know. And just plug it, then just have to do it in the calculator, and you'll get 2.2 times 10 to the power of negative 6. The quantity is also the quantity is also the solubility of copper 1 chloride in ocean water. Because of the dissolution of 1 mole of copper chloride produces 1 mole of copper plus. Therefore, the solubility of copper chloride is 2.2 times 10 to the power of negative 6 mole of liters. Thank you.